Bismillah, salatu wassalam ala rasulillah. Okay, let's start. Now we have to pass to the next step or the next method of reducing Boolean functions or Boolean expressions. The second method is the most used method called the Karnaugh Map. It's a well-known method for doing reduction, and in this part we will try to learn how to use it. First thing first, we have to say that Karnaugh Map is a visual method. We have to draw tables and draw some groups or some sets, and we can use this visual form to perform the reduction. Okay, let's start. We will start like the previous one using exercises. We will try to use an exercises. This exercise is exercises 4 from the problem set 4. Let's see the problem. We have here the first question: extract the SOP and POS from the following truth tables. Just to remember, SOP is sum of product and POS is product of sum. Then use Karnaugh Map using ones, then zeros to minimize the function. We have here to perform two different solutions. Okay, let's start with the first one. We will start with the first one. Okay, we have here our truth table. In this function we have three variables A, B, C, and we have the function. Let's start by the first question is to write, to produce the SOP, the sum of products. The sum of products is the representation of this function, the representation of the function of this truth table. We will express this truth table using this function, using the method, the canonical form called SOP. The base idea of the method is to select the ones on the output. We have many ones on our output. This is the output of the truth table. This is the input. On the output, I have to select the ones. Each one represents a mean term. A mean term is this. A mean term is the writing of all variables. In this case, I have three variables, and they are multiplied. This is why we call the sum of products. The product is here the mean term. We have this mean term. Each mean term represents a 1 on the truth table. In the truth table, I have 4 ones. That means I need 4 mean terms. I need 4 mean terms. Okay, this way they are summed. We have to put the sum here. This is why we call it the sum of product. SOP means the sum of product. I have 4 products and they are summed. We have the sum of 4 products. Anyway, each one here represents a mean term. To express correctly the mean term, we need to check the input for each one. For instance, I have this one. I have to write its input here. We have 0 here, 0 here, 0 here. This mean term should produce the value 1. Okay, I have to write it from above. This mean term, should produce the value 1 if I enter the value 0, 0, 0. That means if A is complemented, if A bar and B bar and C bar and I give 0 to A and 0 to B and 0 to C in the function input, I will get the value 1. This is exactly what I'm looking for. I'm looking for this one. I'm looking for this one. That means I need to put a bar on A, a bar on B, and bar on C. This is the idea. This is the idea, and we have to do it for each mean term. You have to remember, each mean term represents a 1. We found the first one. Let's do the second one, this one. This one has this input. I have to write it 0, 1, 0. Very good. 0, 1, 0. 0, 1, 0. To get a 1 here, I have to put the bar on a 0 input like this. A has 0, I have to put a bar. And I have to put a bar on C because Z contains 0. B contains 1. I don't need to change it. I don't need to change it. And this is the idea. And we can from there extract the rule. If I have a 0 here, I have to put a bar on the variable. If I have a 1, I don't need to put a bar on the variable. This is the idea, this is the trick, this is how we can extract what we call the SOP form. We extracted here the SOP form. Okay, let's continue. The third one is this. Its input is 0, 1, 1, 0, 1, 1. 0, 1, 1, this part. 0, 1, 1. That means I have to put a bar on the 0. The 1, the variable with 1, I don't need to change it. Okay, that's good. We have contain the bar. The last one is 1, 1, 0. It becomes very easy now. When I have 0, I have to put a bar. I have to put the bar here. And this is it. It's very simple. The way we call that the SOP, the sum of products form. And what is this really? This function represents this truth table. If we take this function and extract its truth table, we will get this. We will get this. This is a canonical way or a normal way to extract functions from truth table. We call that SOP. This is a method to extract functions from a truth table. Let's do now the POS. The POS is a product of sums. In this case, we will not use a mean term. Instead, we will use what we call a max term. A max term has this format. We have to put all the variables here. We have 3 variables, A, B, C. It's very easy. We have A, B, C. This is a max term, sorry. This is a max term. This is what we call a max term. Each max term has to represent a 0, not 1. It has to represent the 0 values. How many 0 do we have? We have 1, 2, 3, and 4. We have 4 max terms. Max term is represented by a 0. We have to add them. Let's do a copy paste here to get 4 max terms. Okay, we have the second one. We have the third one. Okay, let's put the last one. We have to put it here, for instance. Okay. Okay. And we have the product. We have a product between the four max terms. This is why we call it a product of sums. Those are sums, and we have the product here, product of sums. Okay, we have to remember each one represents a 0. The max terms represent 0. Okay. Okay. This means that this one should produce a 0. We are talking about this 0. If I input those values, this max term should produce a 0. Let's see it. I have to put here 0 here for A, 0 for B, and we have 1 for C. This sum should produce a 0. I have only one solution. I have to put a bar. I have to put a bar on the value 1. That means C should be complemented. C should be complemented. I have to put a bar on C. This way, if I have 0 or 1 bar, I will get the value 0. This is exactly what I'm looking for. This is exactly what I'm looking for. And here I have to put a bar on the variable C. I have to put a bar on a variable C. Let's continue. This one has the input 1, 0, 0. Okay. I have to write it 1, 0, 0. Same thing here. To produce a 0 here, I need to put the bar on the A. On the variable A, I have to put the bar, and the 1 will become a 0, and I can produce the value 0. Okay, this is it. I have to put a bar here. For the next one, what is it? Sorry, this one. We have 1, 0, 1. 1, 0, 1. Okay, very simple. I need bar here, a bar here. Okay. Bar here and a bar here. The last one, here we have the rule. The rule is very simple. When you have in the product of sum, when you have a 1, you have to put the bar. It's exactly the contrary of the SOP. Sum of products is the reverse. It's exactly the opposite. It is the opposite. The last one, we have 1, 1, 1. Each one should put a bar on its variable. Okay, this is it. This is it. We finished. We have produced a second function. Same thing here. This function represents this table. This function represents this truth table. We finished this part, which is very simple. We have to remember the rule here. On SOP, sum of products, the rule says if you have a 0, you put a bar on a variable. On the second method, the POS, it's the opposite. It's the opposite. If you have a 1, you have to put a bar. You have to put a bar up the variable, upon the variable. Okay, we finished the first part now. We finished the first part. This is the extraction of the canonical forms, the canonical function. The second part is the reduction. Now we need to reduce, we need to do the reduction, sorry, to reduce those formulas. Okay, we have to squeeze some space here. We need some space. Okay, we can put this way. Okay. This part, is here. This is our function. We need some space here. We will write the solution after reduction. Okay, we have just to trace separation here. Those are the original function. We will write here the function after reduction. Let's start with the first method. The first method is related to SOP. That means we will use the ones. We will reduce using the one. If you remember the question, it was you have to do two types of reduction, using ones and using zeros. Okay, we have this table here that represents the Karnaugh map. We need first to fill it. This is the Karnaugh map, and this is the truth table. The first thing to understand is that the Karnaugh map is exactly a truth table. It's exactly a truth table. It's just written differently. The truth table is written row by row, this way. It's written horizontally, row by row. But on the other hand, the Karnaugh map is written in a matricial format. What does that mean? For instance, if I take this cell, for instance, this cell has a column and has a row. I can read the value of the column and the row. I have this is AB 1 1. I can write it. I have AB, the entry AB equal 1 1, and I have C is equal to 1. The rows. The row is equal to 1. That means this cell represents the entry 1 1 1. I can check the initial truth table. I know that the output of this entry is 0. I have to write a 0 here. This is it. It's pretty simple. The Karnaugh map is a truth table, but it's written like a matrix, not horizontal entries, a succession of horizontal entries. It's written like a matrix. Okay, that's become very easy. Now what we have to do, we have to fill all the values here, all the cells here. You can see that we have, how many cells? We have 8 cells for 8 outputs. We have 8 outputs here. Then we have 8 cells here. We can start by the filling one by one. I can check this one, for instance. This is 1 for AB 0 0 and C 0. This cell. This cell. This represents this cell. We have the value 1. We have to put the value 1. We have this value. It is 0 0 1. I have to look for it. 0 0 1. This one. I have to put the value 0. This entry. We have 0 1 0. 0 1 0. This cell, I have to put the value 1. Sorry. 0 1 0. This cell, sorry. This cell, 0 1 0. 0 1 0. Okay. 0 1 0 contains the value 1. We have this one. This one is 0 1 1. 0 1 1. It contains the value 1. Very good. We have 1 here and 1 here. We have this part. This part is 1 0 0. We can say that it's 10 0. 10 0. Contain the value 0. Contain the value 0. Contain the value 0. This part is 10 1. Sorry. I did the mistake. This one was 10, 0. 10, 0 is here. 10, 0 is here. 10, 0 is here. And 10, 1, this is 10, this is 1, this is 10, 1. 10, 1 is 0. 10, 1 is 0. Okay, let's continue. You have the third one. Third one, we have 11, 0. 11, 0. 11, 0 contains the value 1. And we have the last one, 11, 1. 11, 1 contains the value 0. Contains the value 0. This is how we can fill a Karnaugh map matrix or table. This one is exactly the same. We have to repeat that. This is exactly the same process. How we fill the table is exactly the same. The difference is in how we select the boxes. We'll see that later. We'll see the difference between this one and this one. I have just to mention this. This one is for the SOP reduction, and this one means the ones, and this one is for the POS reduction, is for zeros, zeros. Okay, cool. We have to remember that the filling is exactly the same. How we fill the truth, the Karnaugh map is exactly the same for the two methods. Okay, after that, I have to explain one important thing. I didn't do that. I didn't explain how we create rows and columns. I have to explain that. It's very important. Here, I have three variables. I took two variables and one variable. The two variables, they represent here the columns, and the left variables here represent the rows. After division, what we get, AB, we have two variables. Normally we have four values. We have 0, 0 for two variables. We have 0, 0, we have 0, 1, 1, 0, 1, 1. Normally, those should be the values for each column. But you have to observe, to notice that it's not the case. This 10 is put here, and this 11 is put here. Why? It's important to understand that. Why the order is different here? This order is not normal. This order is an order called the gray. I hope I'm spelling it correctly. The gray code. We call it the gray code. The gray code. It's an A here. Okay, we have an A here. It's the gray code. It's the gray code. It's a code invented by someone called Gray, and this code has, by definition, an important point, an important clause to respect. The clause says that to pass from one value to another, you have this clause or condition to change only one variable. What does that mean? Okay, let's delete all this stuff. Okay, and repeat that. What is a gray code? A gray code, if you have a gray code, whatever the number of variables, in our case, we have only two variables. We have A and B. I have two variables. I have to write the values of two variables. I have here four values. I have 0, 0, 0, 1, 1, 0, and 1, 1. I have a condition. The condition is not about the values. It's about the order. The order means that if I start with this, the next one has to follow to respect one condition. The condition is that if you pass from one value to another, you should change only one variable. Not zero variable, Not two variable, but only one variable. For instance, if I pass from this one to this one, I could write 0, 1. 1, 0 is valid too. It's valid. It's valid. Anyway, you can't use 1, 1. Here, I changed two variables. This is not allowed in gray code. Okay, we will take the first possibility, 0, 1. I have 0, 1 here. If I was in a normal numbering, normally I have the value 10 here. I can't use that 10. I can't use 10 here. Why? Because I'm changing two variables. I'm changing the variable, the value of A. This is A. A was 0, becomes 1. Okay, let's delete this X. This is A. A here is 0, becomes 1. And the second variable B is 1, becomes 0. This is not allowed in gray code. You have to change only one variable. This is why we put the value 11. This is why we put the value 11. Sorry. This is why we have to put the value 11 here. We have to put the value 11. Why? Because in this case we are changing only the value of A. Only A is changing here. This is A. This is A. Okay, and the last one. Okay, we have to put 11 here. The last one, the left one, is 10. We can put it, of course, 10 here. I'm changing only the value of B. B was 1 and becomes 0. A is not changing. A is always with the value 1. Okay, we practically finished. Practically, we're not finished yet. The last thing, you have to be sure that the last one is respect the same rule with the first one. We are creating a circle. We are creating a circle order. The last one, passing from the last one to the first one, only one variable to change. In this case, it's the value of A. A for the last value is 1, it becomes 0 here. A becomes 0. We are changing all the value of A. This is a condition to use Karnaugh Map. The order of let's delete this. The order of the columns and the rows too. The columns and the rows should use the gray code order. You have to follow the principles or the conditions of the gray code, ordering the gray code. This is the same here, but this is very simple. You have only one variable. You have only one variable. You have two positions, and it's perfectly applied to the gray code ordering. This is it. This is a condition to order columns and lines. This is the same here. This is the same here, and we will see after that the next example. We have 4 variables when we have to use 4 columns and 4 lines, 4 rows, 4 columns and 4 rows. Okay, this is it. We have to respect that. We have to use the gray code. Okay, let's continue. Let's pass to the next step. The next step. In this part, I said we are using the sum of product, SOP method. The SOP method is based on the ones, here. What we can do here? We have to create boxes. Visually, we have to draw boxes. What is a box? This is a box. This is a box. This is a box. A box is a set. It's just a set. I am assembling many cells together. We call that a box. This is a box, for instance, etc., etc. We have to form boxes. Why we need to form boxes? Actually, the box is the way to reduce the terms, is the way or the path to reduce the terms. This is the way used to reduce the terms. Okay, how can we form the boxes? We have many conditions to remember here. You have practically 4 rules to follow, to respect, while creating boxes. The first one is that a box should contain only once. A box like this is not valid. It's not valid. We have a 0 here. A box should contain only once. The second rule, the dimensions of a box should be the power of 2. For instance, this box has the dimensions of 1 by 2. We have the width of 2 and the height of 1. Those 2 dimensions, they should be the power of 2. Power of 2 means 1 or 2 or 4 or 8 or 16 or 32, etc., etc. This is it. That means I cannot create a box like this. A box like this is 1 by 3. 1 by 3. 3 is not the power of 2. 3 is not a power of 2. This is the second condition, or the second rule. The third rule is to create the biggest, the largest box possible. For instance, let's examine this. Let's pretend we have a 1 here. We have a 1 here. What I can do, I can create this box, for instance, 2 by 1. And this box, I created 2. This is a bad solution. Why this is a bad solution? The best solution is this, is to create a box, the largest box possible. I create a box of 1 by 4, like this. I have to create the largest box possible. Even if the boxes intertwine, it's not a problem. Here we have intertwined boxes, but this is the best solution. Okay, this is the third rule. The last rule is that you have to get the minimum number of boxes. For instance, if you have a solution with, let's say, 3 boxes, and another solution with 2 boxes, the 2 boxes is the best solution. Let's take an example. Let's suppose we have this box, for instance. Let's pretend that we have 2 boxes here. I could not take this one alone. I have to create the biggest box possible, like this. Here I have 3 boxes that covers all the wand. Here the condition is related to the covering. We should cover all the wand. There is no one uncovered here. They are all covered. Here I have 3. I could also use this solution or give this solution. In this solution I have 2 boxes that cover all the ones. This is the best solution. I have the last rule, I have to repeat that, is you have to cover all the ones with the minimum number of boxes. In this case, I have 2 boxes to cover all the ones. This is the best solution. It's better than get 3 boxes like we did previously. Okay, Those are the 4 rules to follow to draw boxes. Let's do it. Let's do it for our example here. We have 0 here. What we can say, I can, for instance, draw a box here. The first one is here. I can't do that because we already said that it's not possible to get a dimension different from the power of 2. It's only possible to do that. Of course, it's not permissible to use diagonal boxes. The diagonal boxes are prohibited. They are not allowed. I can do that. This is not possible. I cannot choose only one. I have to include it to a bigger box. This is the third rule. I have to get the largest possible box, even if multi-boxes are intertwined. For this one, we have the same rule. I can't choose this one by himself. I have to create the largest box possible. Okay, we finished. We covered all the ones. The zeros are not covered. We covered all the ones. In this case, each box represents a term. We have 3 boxes. Each box represents a term. And now we can do the reduction. Okay, let's clear a little bit this diagram. Okay, we have this first box. What we can say, this box represents a term. I have to write my mean term here. I have to repeat that. We are working on the product of sum. We have this term. And now I need to check the variables, the values of the variables. I can say here, for instance, this is AB. AB in this box gets 2 values. The value 0, 1, this one. Okay, we have 2 values. AB gets 0, 1 and 1, 1. The variable that changes should be eliminated. And we can see this is the variable that changes. It's A, it's the first one. It's A. I have to eliminate it. This is the process of eliminating the variables. I have to check C. If I check C inside the boxes, C is 0. It doesn't change. The C don't change. C don't change. I can't eliminate it. Okay, now I have to check the values left after the elimination. After the elimination of variables, I have B equal to 1 and I have C equal to 0. In this case, I have to follow the same rule used here. The rule used on SOP said that I have to put bar when the variable is equal to 0. In this case, I have C equal to 0. I have to put the bar upon the C. And this is the resulting term. I have to write it. Okay, let's write it. Let's write it here. We have this one. Okay, let's clean our solution. Okay, have this one here, and we found BC bar. BC bar. Okay, I have to continue. Let's see the next box. The next box was here, and you have to do the same thing. We have 1, 1. We have to check those 2 values. We can see that this variable changes from 0 to 1. It's b. b is eliminated. b is eliminated. The left variable a is 0. I have to put a bar here. And the c is equal to 0. It's not eliminated. And I have to put a bar 2. I have to put a bar 2. It's a bar, c bar. A bar, C bar, sorry, C bar, A bar, C bar, and we have the last one. If you remember, the last one was this box. This box, we can see the value of AB. The value of AB don't change. We have A equal to 0, we have B equal to 1, and inside this box, this value, the value of A, B, they don't change. We have A bar because the value of A is 0, and we have B without bar because B is equal to 1. Let's look, we have this one. Let's look on the arrows. We have here the C that changes from 0, the C changes from 0 to 1, C is eliminated. C is eliminated. The C does change in this situation. We have A bar B. A bar B. Okay, I have to clean first. Okay, A bar B. That is it. That is it. We have the solution. This is the reduction. This is the reduction. We get the reduction of this function like this. We reduced many variables here, and we reduced also many operations here. We reduced many operations. This is the reduction using ones or using the SOP. This is a reduction using SOP. Okay, very good. Let's continue. Let's continue now. We have to use the POS method or the zeros method. The POS method or zeros method is exactly the same, but this time we should box the zeros, not the ones. The same rules, the 4 rules of boxing, these are applied for zeros. And they are exactly the same. They are exactly the same. We have the first rule is that a box can contain only zeros, no one inside. The second is that the dimensions are the power of 2. The third rule is that I have to get the larger box possible. And the fourth rule is that I have to get the minimum number of boxes. I have to get the minimum number of boxes. Okay, we can try here. I have 0, 0. I cannot enlarge more. I have this box. This is 0. It's not a wise idea to put it alone. I have to add it there to get a bigger box. This one, normally it should be isolated because it have a neighbor. The neighbors here one. Neighborhood, we have here one, and here one, but the Karnaugh map are what we call, they are circular. What does that mean? Circular means that these 0 have a left neighborhood. This is 0. This 0 is the neighborhood of this 0. The Karnaugh map is circular. We say that The Karnaugh map is circular. This cell is the neighborhood of this cell. It's in the neighborhood. This is the neighbor of this cell. This cell is the neighbor of this cell. This is circular. Circular horizontally, and we have also the same thing vertically. What I can say, this cell is the neighbor of this cell north. The neighbor of this cell north is this one. The Karnaugh map is circular vertically. Okay, good. What I can say here, this is 0. I should take the biggest box, the largest box, with the power of 2, of course. I cannot continue to this 0. The power of 2, I get this 2 zeros. Very good. We were able to draw the boxes. Now, each box represents a max term. A max term is this. We are working now with the zeros, with the product of sum. We have this is a max term. We have a sum here. We have a sum. We are working with the rule of this formula. We have a sum here. Each box represents a sum, but we have to eliminate some variables. Okay, let's for instance take this box. This box. If I look at this box, if I look at the columns, I have only one column. Only one column. That means A, B, they don't change. A, B, they don't change. I don't have to eliminate any variable here. But I have have the value 1, B have the value 0. What can I say here? I have to remember the rule used here. We used 1 has to have a bar and 0 with no bar. This rule used in the product of sum. This means I have A and B here. A is 1, I have to put a bar here. B is 0, I don't have to put a bar here. Now let's look at C. C has 2 values here in this box. Has the value 0 and the value 1, that means that the C should be eliminated. And I got this term, A bar plus B. A bar plus B. Okay, this is, of course, product of sum. This is a product of sum. Very good, very good. Let's see the next one. Let's, for instance, study this one, this box. When I look at this box, I have to check the variables here. I have 2 values. I have 2 values. I can tell that B is changing here. I have to eliminate it. B is changing. A is not changing, but it's 1. I have to put a bar here. We are on product of sum. And I have to look the value of C. The C is not changing. It has the value of 1. I have to put a bar on C. The solution is A bar or C bar. A bar or C bar. Okay, and the last one is this one. This one, if we look at the columns, we have 2 values on this box. We have 2 values. We can tell that A is changing. A here has the value 0, and here the value 1. What's left is B. B is 0. I don't have to put a bar here, and A is eliminated. A is eliminated. C, in this box, the C has 1 value, the value that don't change. The value is 1. The value left is 1. 1 means that I have to put a B here. A bar here, sorry. A bar here. We have here B or C bar. B or C bar. Okay. And we finished. We finished the solution. We finished the solution here. You have to clean it a little bit. We have B or C bar. B or C bar. And this solution is the reduction of this function. The function of product of sum. The reduction of a product of sum. And this is it. This is it. This is how you can reduce. We have two solutions here. One is enough, to be fair. One is enough, but in our studies, we use two different solutions. We use two different solutions. This is it. We have to continue. Let's pass now for another complicated exercises. In this part, we will use for variables. You can see here that the matrix or the Karnaugh map is doubling its size. Why? Because using this variable D, we have two more rows. You can see that we still using the gray code. We are still using the gray code. But the first thing to do, we have to try to get the SOP and POS. To do so, it's exactly the same method that we used previously. We have here mean terms. Each one represents one mean term. Mean terms have to contain all the variable, the multiplication or the product of all the variables. We have here one mean term. You have to see how many one do we have. 1, 2, 3, 4, 5, 6, 7, 8. That means that we have 8 mean terms. First one, second one, have 4 here, and we can repeat that again this way. Okay, very good. We have 8 mean term. Each one is represented by 1. If I take this one, for this part, we have 0, 0, 0, 0. That should produce 1. We have to put a bar for each 0. We have bar here, and bar here. Okay, the next one, we have this one. This one is 0, 0, 1. Same here. For each 0, we have to put a bar. Okay, the next one is this one. We have 0, 0, 1, 1. I have to write it directly now. We know the rule. If you have a 0 on a variable, you put a bar like this. A0, put a bar. B0, we put a bar. And we have 1, 1. Okay, for this one, what do we have? 0, 1, 1, 0. That's mean bar, not bar, not bar, bar. Okay, for this one, what do we have? 1, 0, 0, 0. That means A don't have a bar, the others we have bar, bar, bar. This one is 1, 0, 1, 1. The 0 is on B, we have B bar. This one, we have 1, 1, 0, 1. That means the bar is on C. And this one, we have 1, 1, 1, 0. The bar is on D. Very good. It was very easy. The same here, we can do the SOP format. Same, we are dealing now with what we call max terms. Max terms is an addition. We have A and B, or B, or C, or D. Very good. This is a max term. We need to duplicate it this way. Okay, we need a duplication here too. This way we get those parts. I don't have space. Okay, let's see what we can do. We have okay, it's possible to squeeze this a little bit just to get more space. Okay, this way. Same here. Same here. Okay. We should have 8. This is weird. We can't get enough space. Okay. This way, it's possible to get more max terms. Okay. We have 8 max terms. We have 8 max terms, and now let's see the max term is all about the zeros, and we need to put the max term to 0. In this example, we have 0, 0, 1, 0. The 1 should get a bar. The 1 is C, gets the bar. We have this 0, and we have 0, 1, 0, 0. The 1 is on B. We have B bar. This one, we have 0, 1, 0, 1. That means bar on B and D. We have this one, which is 0, 1, 1, 1. We have 3 ones here. B, C, D bar. This 0, we have 1, 0, 0, 1. You have a bar on A and bar on D. We have this one, 1, 0, 1, 0. That means A gets a bar, C gets a bar. We have this one. We have a bar on B and on A. And we have the last one, all bars. We have bar, and bar. Very good. It was very easy. Those functions are, this one is called the sum of products, and this one is called the product of sum. Okay, now let's see how we can do the reduction using the Karnaugh map, using the sum of products, using ones. That means using ones. Let's fill the Karnaugh map. We will fill first the ones, and what's left is zeros. We have 1 on 0, 0. This is 0, 0, 0, 0, 0, 0. We have a 1. This one we have 0001, 0001. This one is on 0011. Very good. This one is on 0110. Okay. 0110. It's there. Okay. 0110. Where was it? It was there. We have this one is 1000. 10 is there. 00. Okay. And we have this one 10, 11. We have 10. 11 is here. Have 1. We have this one on 1101. 1101. And the last one we have 1110. 1110. Very good. We got all the ones. We can do the same for, we can fill what left as zeros. Okay, and we finished. We finished the filling of the values of the Karnaugh map. The same here is for the zeros here. The second one is when we draw boxes around zeros, but we have the same values. Exactly the same pattern. Okay, now we can start the drawing of boxes. We will start with ones, and we have to look. This is more complicated than the previous one. What we can do, let's for instance look at this one. This one is totally isolated. We have on the north we have 0, on the east we have 0, on the west we have 0, on the south we have 0. This one is totally isolated, and it's impossible to draw a box of multiple ones in this situation. We have those two ones. You can say, see those two ones. We have a 0 here, we have 0 here. If we look at south, we have also zeros. Those zeros are on the south of this block. Okay, you have to put it by itself. We have a box here. Okay, let's continue. If we look at this one is not totally isolated. We have 0 here, 0 here, 0 here, but we have this part, we have 1 here. We have a 1. Okay, we can get it. We can get it. We can put those two one together. This one with this one. And this is a maximum that we can do. We cannot add this one or this one. This one, we cannot add this one too. Cannot add it. Okay, let's continue. Let's look at this one, for instance. This one has 0 on south, 0 on west. He has 1 on east, and north he has 0. Okay, we can take the east. We can take the east and add this one. But you can see we cannot build a box more than 2. It is the max 2. What's left? Okay, we left with this one. This one has a 0 on right and 0 on left, but it is always possible to add it with another one, even if they are interlaced or intertwined. It's not a problem. The third rule, you have to remember that you have to take the big box, the large box. We took this one. We have one with this one. Even we have intertwined boxes. It's not a problem. It's not a problem for the intertwining of many boxes. Anyway, I guess we covered all the ones. Yes, we covered all the ones. Now we can write the expression for each box. Okay, let's write it here. Up, we will put it here. I hope we will get enough space. Okay. Okay. Let's start with this one, for instance. This box. If we look at this box, we can see that those two values we have the A changing. We have to delete it. We have to delete the A, left the B. The value of B is 0 because we are using min terms. That means we have B bar. We have B bar. Okay. Let's clear this one. We have B bar. Good. What's left? CD. If we look here, this box is limited only on one value. C is equal to 0, D is equal to 0. That means we have C bar, D bar. C bar, D bar. Very good. Or we are using the sum of product, of course. This one, we finished this one. Let's see this one, for instance. This one. If we look at this one, it's the same. We have those two values where the A is eliminated and B is complemented. Okay, let's write it. We have B bar. And here in this situation, we have C is equal to 1, D is equal to 1, and they're not changing. They are not changing. That means there is no bar. We have B bar, C, D. Very good. We finished with this one. This one, let's see this one. This one, in this situation, we have this value and this value belonging to this box. You can see that the A is changing too. The A is changing too. And we are left with the B, with the value 1, which means there is no bar for the B. Okay, good. We can write it. We have a B here. In this line, on this row, what do we have? We have CD. C is 1 with no bar. That means there is no bar. And we have D bar because D is equal to 0. We have D bar. Very good. Very good. Okay, let's continue. We are left with this one and this one. Let's do this one. Let's do this one. We have, on the columns, we have only one value. A 0, B 0. That means we have A bar, B bar. A bar, B bar, okay? But on the lines, we have two values here. We have this one and we have this one. We can say that the C is changing. We have to eliminate it. And we are left with the D with 1. D with no bar. Very good. And we have D with no bar. Okay, what's left? This one is the last one. This one is the last one. We have this value and this value. There is no variable that changes. That means there is no variable to delete. There is no variable to delete. We have 1, 1, 0, 1, 0 for C. We have C bar. We have C bar. That means we have A, B, C bar, D. Very good. And this is the solution for our reduction. This is the reduction of this function, of this expression, or of this function. Very good. Very good. It was easy. Okay, let's continue. Let's see now the product of sum the product of sum. That means we are dealing with zeros. We are dealing with zeros now. And we are reducing this function. Okay, let's see here how we can aggregate, how we can reassemble the boxes. We have those two zeros, for instance. If we look up the north, we have 1, 1. We can now add more zeros on the up. On the left, on the right is the same, we cannot add. And we cannot add on the south too. We cannot add this one. We cannot because it's unique. It's only one. Okay, we have the first box here. We have this box. First one. Very good. We can add a box here too. This box is surrounded by ones. Particularly, they are all ones surrounding this box. Okay. We have those two zeros. We can add them together. This one and this one. We have to check in the south we have 1, and here the same south we have 1. We cannot add on the south. Okay, very good. We have the third box. We are left with 2 zeros. We have this is a 0. We can easily see that this 0 is surrounded by 1s. It is surrounded by 1s on the 4 directions. That means this 0 by himself is a box. This one, it's easy. We can take a box, the lower box or the upper box. We can also take this one. We can also take this one, but not a solitary 0, but not this way. We have to take the biggest, largest box possible. I guess we covered all the zeros, yes? We covered all the zeros. Now we have to write the formula. We have to write the formula. And we have to remember that we have max terms here. We are using max terms. Max terms means it is A or B or C or D. Very good. Let's start with the first one, this one, for instance. For this one, what do we have? We have this value and this value on the column. We can see we have to delete the A. The left B is 1. In this case, it's the reverse of this one. If we find 1, we have to put a bar. We have to put a bar on B, and we have to delete the A. On the max terms, while covering the zeros, when we have 1, we have to put a bar. And in this form, the SOP, we have to put 1 when we get 0. Here, we have to put a bar when you get 1. Okay, very good. Okay, we have no A, and we have B bar. And this, on the lines, we have CD with 0, 0, means with no bar. CD. Okay, this is the first. This is the first term. This is the first term. Let's see the second one. Let's take this one, for instance. This one, and we have a multiplication here. We have a NAND here. Okay, here it's exactly the same. We can tell that we have A eliminated and B bar. Okay, we have B bar, or, and we look at, when we look at this, we have C is equal to 1, D is equal to 1. That means C bar, D bar. We have C bar, D bar. Good. We have C bar, D bar. Okay. Okay, let's continue. Let's see this one. This one. This one we have how many values? We have 2 values. The variable changing is A, and what's left is B with a 0. That means with no bar. We have B, or we can see this value. We have 1 on C bar, and we have 0 on D. This way. Very good. Very good. Have this one. Okay, we have to add it here. The next one, we finished this one, and this one, and this one. Well, let's do this one. Let's do this one. This one. This one, we can tell that, what do we have here? We have no changes, no deleted variables. We have A with 0, B with 1. That means we have A, B bar, A or B bar, sorry, or B bar, or when we look on the lines of on the rows, we have the C that was eliminated, and what led to a D with the value 1, that means D bar. That means D bar. Okay, we finished with this one. We have to add it here. Okay. What's left? The last one is this. The last one is this. This one is pretty simple, we can tell. Okay, forgot to delete this. Okay. We have this one. This one, we can say it's pretty simple. We have only 1, 0. There is no change. There is no change. We have all the variables here. There is no deleted variable. A or B or C or D, like this way. What do we have? A is 1, we have to put a bar on A. B is 0, we don't have to put a bar. We have C, 0, don't have to put a bar. And we have D with 1, we have to put a bar. This is it. This is it. We get our last term. And this is the solution of the reduction. This is the solution of our product of sum solution. Okay, and this is the demonstration how we can reduce using the Karnaugh map. Just to remember, this one is the reduction of this expression. Okay, thank you very much.